We need to determine the coordinates of the point located on the line segment connecting the points P, 3, -4 and Q having coordinates -2, 5, which are twice as close to P as they are to Q. So let's try to understand the problem graphically first. So here we have a point P and its coordinates are 3, -4. And then we have another point Q with coordinates -2, 5. So let's join the 2 points by the help of a straight line. Let's join the 2 points using a straight line. Now we are going to consider a point, let's say somewhere lying between P and Q, and we're going to consider it having the coordinates x, y. So our goal will be to determine the value of this particular point. The coordinates of this particular point are with the condition that is twice as close to P, meaning we have two lengths, PR and PQ. So PR is going to be twice as close to P as they are to Q. So that means PR is equals to 2 times RQ. In other words, if we rewrite this, then we have PR to that of RQ. This will be 2:1, or we can say that the point R divides the line PQ in the ratio 2:1. Now, with this information, we can easily find out the coordinate of point R using the section formula. All we have to do is take 1 multiply with Q, and then we can multiply 1 with P. Fine. So let's obtain the coordinates of point R. So to find out the x coordinate, we'll take 2 and multiply it to the x coordinate of Q. So that's -2. Added to 1 times the x coordinate of P, so that's 3. Divided by the sum of the ratio, so that's 2 plus 1. And then for the y coordinate, we take 2 and multiply it to the y coordinate of Q and add it to 1 times the y coordinate of P, so that's -4, divided by the sum of the ratio, so that's 2 plus 1. Let's obtain this value, so we get 2 times -2, so that's -4, added to 3, so -4 plus 3, that's going to be -1, divided by 2 plus 1, so that's 3. Then we have 2 times 5, that's 10, minus 4 times 1, that's 4, so we have 6 divided by 3, so that's going to be simply 2. So that means the coordinate of the point R is going to be -1/3, 2. This is the point, and it's lying on the line joining P and Q in such a way that it's twice as close to point P as they are from point Q. However, this is not the only possibility. Now, in this particular example, in this problem, we see that R is dividing P and Q internally. The other scenario could be that R could divide the line PQ externally, yet it could still follow the condition that it is twice as close to P as they are to Q. So let's try to understand that particular section as well. So we have the point P. P has the coordinates 3, -4, and we have the point Q. Q has the coordinates -2, 5. Now this time we're going to consider the point R to be in such a position so that it's twice from the distance P as it is from Q, which means that this distance, if it is 2 units, then this is going to be 1 unit. So this is twice as far away from P. R is twice as far away from P as it is from Q. So here we can say that R is dividing P and Q externally. So that means we'll have to use the external section formula. So that's quite similar. So we'll take 2 and multiply with Q. We'll take 1 and multiply with P. Okay, so let's find out the coordinate of point R. So that's going to be, we'll have 2 times the x coordinate of Q, so that's -2, but this time we'll have to subtract. So we'll have to take the subtraction of 1 times the x coordinate of 3, divided by the difference of the ratio, so we have 2 minus 1. Then the y coordinate will to have 2 times 5 minus 1 times -4, divided by 2 minus 1. Okay, so let's simplify the value. So here we have 2 times -4. So that's 2 times 2 is -4. And then we have -3. So -4, -3, that's -7 divided by 1. And then we have 2 times 5, that's 10. 10 plus 4, that's 14. So we have 14/1. So our point is going to be -7, 14. Fine. So this is the point R, coordinate of the point R, such that it is twice as far from P as it is from Q.